Hi, I'm Haozhe Liu, and I will use this video to apply for the TA positions in fall 2022. And in this video, I'm going to introduce several similarities to build a similarity-based recommender. This is also the course content, what we learned in course CICE 255. Assume we have a group of data as our input, and in the data, there are a lot of users with the items they purchased or interact with before. And also, from the other direction, we have a group of items and the users who ever interact or purchased the item before. And the question is, how can we measure the similarity between the two users? The answer will be, we can do so in terms of the items they purchased before or interact with before. And from the other direction, the question can be, how can we measure the similarity between two items? The answer will be, we can do so in terms of the users who purchased the item before. Here is an example from Amazon. So when we buy something on the Amazon, it will always do some recommendations to you. The recommendations will based on the customers who will the items also will, and the customers who bought the item also bought. So this is kind of similarity-based recommender. The recommender will make some recommendations based on the similarities between the users and other users who also viewed this item before. Here's the definition. So I subscript U means the set of items purchased by users U, and the U subscript I means the set of users who purchased item I. And there is another way to express this kind of size by using the matrix R. So the columns are each users, and the columns are each items, and the rows are each users. And zeros means the users haven't interacted with the items before, and one means the certain users purchased this item before. So the I subscript U can be expressed by the items I, and for the items I, the matrix R subscript U I equals to 1, and UI can be expressed by the users the R subscript UI equals to 1 in the matrix. So another important concept is the elucidant distance. The used subscript this one means the users who bought I but not bought J, and this one means the users who bought item J but not the item I. And we can use a graph to express the idea. So this one is the UJ and this one is UI. And this region is the users who bought I but not J can be expressed by this one. And this part is the users who bought J but not I can be expressed by this part. So this is the similarity difference between the users UI and the UJ. Here is an example. So the users who bought, there are 4 sites in total. The U1, U2, U3, U4, and this one is the users who bought item in 1 but not in 2, and plus the users who bought the item 2 but not 1. So the first one will be 0 because like all of the elements in U1 also in U2. And the second part is we have like 138, 135, and 16. There are 3 elements in total. So the final result will be 3. And this one, the 5 is not in 4, so it is 1. And the items in set U4 but not in set U3 is also 1. There is 1 element 5, so the final result will be 2. So after we know all of the basic concepts and the equations, let's let's continue to introduce the similarity. The first one is the J-cut similarity. The J-cut similarity can be expressed by the set A intersection with the set B and the set A union with set B. And also we are not going to consider the content for the result. We only consider the number of the results in total. So we use the norm right here. And it is the same thing for the U subscript I and the U subscript J. It will be U subscript I union with UJ and divided by UI union with UJ. We can also use a graph to express this idea. So the numerator will be the intersections for the UI and the UJ, and the denominator will be all of the elements in this graph. So the J-cut similarity in one word will be how large is the intersection compared with the union. So the next similarity is cosine similarity. So sometimes we are not going to consider whether the items purchased by user or not, but the feedback from the users. So the users will maybe bought and like this item. So we use 1 to express this situation, and the users didn't buy this item at all. We will use 0 to express this situation. And sometimes there are -1. It means the users bought this item but have some negative feedback. So this time the J-cut similarity is not working, and that's why we introduced the cosine similarity. So the cosine similarity will have two vectors. One is vector A and one is vector B. So the cosine theta can be expressed by A multiplied by B divided by the length for the vector A and length for the vector B. And we use the we express it in the set expression. It can be A intersection with B and divided by A norm and the B norm. So this is the cosine similarity. Cosine similarity. So next one is the Pearson similarity. Sometimes we are not going to use the 1, 0 or -1. We are going to use some numerical ratings to express the feedback from for the users to the items they purchased before. And that's the time when we need to use the Pearson similarity. It is very similar to the cosine similarity. The only difference is before you calculate the intersection, you need to minus the average value. So for example, we are going to consider the similarity between the group U and group V. So before we directly calculate the items purchased by U is IU, and the item purchased by user V is IV. So the numerator will be IU intersection with IV. And this one, before we directly use the value in the matrix R, we need to minus the average value right here. And for the denominator, we are going to do the same thing. Before we need to calculate the norm value, we need to minus the average value. So this is the equation for the Pearson similarity. And finally, we have a kind of comparison between the Pearson similarity and the cosine similarity. So this is the equations, and when we need to write some codes, we can further understanding how it works for the 3 different similarities. And they are very important, and we need to apply all of them in our both exam projects and our homeworks. I think that's it. In this video, I introduced and explained the 3 similarities: the J-cut, cosine, and Pearson. And if you guys have any questions, feel free to send me some email or raise up your hand in my office hour. I'm very happy to answer all of your questions. Thank you so much.